From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We are putting together infrastructure that supports this certification. Now, how would you put this infrastructure? You can do a traditional methods of it where you have processes. I mean, even the non-traditional, non-additive manufacturing processes that it goes through to, digital tools. You have those tools are involved. Rarely products are manufactured now on a piece of napkin. They are using those in there. But what we see, additive becomes very important because in terms of digital, because essentially additive is a digital manufacturer.
That's Faisal Iqbal. Faisal is the head of digital for Baker Hughes Additive Business Services. I first met him at the ASTM ICAM conference last year, where he delivered an insightful talk on how his team is tackling data management within their organization. With a wealth of experience that traces back to his time at GE, Faisal brings a unique perspective on the intersection of additive manufacturing and digital transformation. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, data management, or general additive manufacturing support, reach out to our team or through our website or via email at info@3degreescompany.com. Well, thank you so much for joining the show today. We're excited to kind of continue the conversation we started at ICAM this year about manufacturing and 3D printing and data management. But before we begin, as we begin, I always like to start at the beginning. So, where were you born? Do you remember any of those kind of early days of inspiration for manufacturing or what you're doing today?
Yeah, so originally I was born in Pakistan, right? I came from my schooling here pretty early in age and went through the schooling here in US, in Michigan, and been around kind of few states, and right now I'm in Houston. Yeah, so engineering it's something was part of I don't know if I call it DNA, but it was just something, an inclination from childhood, trying to break things, build things. With most of us in engineering career, that's how they start, right? And then from there, I went into mechanical engineering. So by my background is core engineering, mechanical. I think it was one of those choices that among the electrical and the computer science, and somehow I wanted to have that core knowledge of engineering. I went through in there, although I ended up in my career was more and more systems engineering and eventually more now what is called digital. But so did my master's here, and then from mechanical I got into more manufacturing side of it, and then again the graduate program was mostly focused around a lot of manufacturing related, computer and manufacturings, and then digital manufacturing, at least in talks in academia, was already around 20 plus years ago. Maybe not in full manifestation, but at least the professors were talking about it. So I got inclined to that as well. And then I joined a company, which is now, it's Siemens, right? But it was mostly working on automotive with General Motors for a long time. And then I switched basically, there's only one employer I switched, I guess. From there, I moved to GE, and then somewhere around 2007.
Did you ever?
Yeah, go ahead.
Did you have any industry that you wanted to kind of be part of during kind of even those early days or in school? Was drawing into?
Yeah, it's a good question. When I look back, I think it's so I read so automotive was I wanted to join, and that's why I think I ended up there in Michigan as well, being the automotive town there. I think when I was in my teens, I read this book. I'm forgetting the name of it. It was by Lee Iacocca, the guy who kind of transformed the Chrysler, right? And it was very fascinating. At that time, I was not even engineering. I was just what he went through the nitty-gritty details. So it was always a fascination about the cars that kind of kept me there. Um, and then even when I left the automotive, I kind of moved into other industries, aviations, and then energy. Where I'm in. But there was a little bit of that early child, affiliation a little bit with the automotive. I think that's where it started. So that I remember. I don't even remember the book name, but I remember one of those summers, you're ninth or 10th grade in there, and then you have nothing to do but just read. Definitely, I could tell you, the phones were not there when I was there. So yeah, it was yeah, absolutely. So that's how kind of I started. Yeah.
Yeah, and so you mentioned kind of the early days of digital engineering, digital manufacturing. What did that look like in your mind back then? Kind of when you first started to hearing about it and hearing talks and seeing people implement it.
Yeah, so. Of course, when you were in school, your professor kind of make it sound like this is happening in in the real world out there, so I thought a lot of things the devices are connected and because of course this you would have. Robots were still, we're building it. So most of the car body was done by the robots there. So that there was that part of it there. So there was a lot of automation already in place, not to the extent what is now. In 20 plus years, it has changed, dramatically. But at least the thought was that we follow a digital model of a product, and it kind of goes through the whole life cycle of its development, including the manufacturing. Now, fortunately, I got involved into groups and the roles, even in automotive world, where a lot of this advancements already in place, meaning they were, alongside, I think, aviation, those were two industries, they were far ahead in terms of implementation of digital practices and tools as well in there. So that was a good part of it. But I did realize going there, the one tool that I never thought that's such a prevalent is the Excel. Excel is the master for all the manufacturer. So trying to change the folks from out of the Excel based it was interesting experience, and to this day, you go to most of the manufacturing, shops. Folks are comfortable with what they got through Excel, and it does wonders for them, I guess. Yeah.
And so as you work with kind of quite large companies, right, to start out with, what were some of those challenges early on, right? You mentioned kind of the fighting of the status quo with Excel. Is that how do you get over that barrier, right? Because people are continuing to get more digital or have kind of efforts in that front. But what if you reflect back on kind of what you've seen in your career, where does the rubber meet the road, where people are like finally submit to say, okay, I'll change?
Yeah, I think it's what I can, when I reflect back, at the time when I had just started career, you're 20 something and you just got out of college and you're working. A lot of those things don't kick in right away, but it's like what I see and I reflect back, it was all culture. It was just the folks were used to doing those things the way they were doing it, and it was efficient way in their mind. And to make them change or make the processes change, it was always you have to prove to them. You have to prove it to them that the process you're putting in is much more efficient, and it's not out to replace them. It's out to replace the non-value added work. And in cases where those things were articulated and demonstrated clearly, I or the team that I was working with was clear success.
Yep.
Wherever this articulation was a little bit blurry, murky, abstract, and that's where challenges happened, mostly in that case. And I guess to this date it's the same philosophy because the individuals, which basically around which the culture kind of evolves, and the collection of, and until it's proven clearly.
Yep.
It is very tough to just kind of basically showing a bunch of PowerPoints and saying, trust me into it. But yeah, we all had successes and had failures as well, which kind of taught, like, okay, how do you kind of present your value proposition of the process you're changing, or a tool you're bringing in, or the ways of doing things differently.
Yep. And so you and I met in the context of additive manufacturing and the work you're doing in the oil and gas space. Maybe let's take a 30,000 foot view first, and for those who are kind of somewhat new to the space, but how are oil and gas companies or kind of that industry thinking about additive manufacturing? And then we'll kind of dive into some of the work that you're doing and talk about that.
Yeah. Okay. So let me kind of introduce the company I am is in Baker Hughes, right? It's one of Fortune 500 companies, $40-some billion US market cap. And so we are a market leader when it comes to product and services, what used to be traditional oil and gas services, but now it's a broader energy industry in there. So that's where, although we've been, as a company, we do go beyond energy as well. So when you look at it, we have kind of two segments there. One, we're focused on traditional oil and gas, the services or products and solutions where we're improving our customers' operations with our services and products as well. But then we have an industrial segment where we go into areas of gas technologies, assets management. So those are two things there. But over the past 5 or 6 years, maybe more, although it's part of our culture to invest a lot in R&D towards the newer and newer products that we deliver to our customer base. Of lately, we've been, the company has been investing quite a bit in emission management, decarbonization. So there's a lot of focus towards digital as well to improve the customer operations. So I'm all bringing all this new tech into the company and use it and to improve, our customer experience with our products and services. One such technology is additive. That's where the company is spending quite a bit as well. And why additive, you want asked. So the way we see it from our end is additive is the way that we can also improve or increase the value of product and services to our customer. And how you would say, because if you look at it, additive gives us the opportunity of this free-form design. What used to be very complex, bounded by traditional manufacturing, those product designs, you don't really have to bound your geometrical features and others towards the typical or traditional manufacturing. So you get this opportunity to come up with products that could be very efficient and improve better functionality in there, because you can do that. You can have through additive, you have an alternate fabrication method also. So it's not like you're kind of focused on castings and forgings typically in there, but you can really speed up with additive. You can really shorten your cycle as well. And when you take these two things, an efficient, eco-friendly product faster time and then shorter time to the customer, perhaps even localized production. All of that combined also gives us the opportunity to improve the sustainability impact as well. So those are three areas we look at it from the additive perspective, why we use it. And essentially, we are improving the product performance, accelerating our production, and just the cash flow.
And when you say like product, what do you mean in that context? And like in terms of volume as well, like it's not a car where you're producing millions of parts.
Yeah.
Right? Like what do you like? What comes to your mind, or what do you visualize when you say product, or kind of?
So for us is we don't make millions and millions of cars. No. So
Yeah.
ours is very essentially. This is why additive becomes even more critical for us. Our products are very customized to the operating conditions. So we're talking about gas turbines. We're talking about the drill bit that goes in there.
Yeah.
I know I didn't mention individual products, but these are typical products that we have. But each of these, let's say, operating conditions, customers' wells, or the needs for the refineries, pressure flows for our industrial well, they are all unique in many cases when we go to. So we have low volume, but high customization.
Mm-hmm.
And that fits very nicely for these highly customized and low volume areas there, that you can truly customize your products for the unique need or a specific need from a customer side of it. And then that puts us, really in a well-head, far ahead from the rest of the traditional manufacturing methods.
And I imagine too, not only do you have to have customization, you need part of the digital fingerprint traceability is also about standards, requirements, and safety.
Exactly. So yeah, you brought up this, and that's the conversation we had there, right? So people I think generally think, okay, FAA, airspace, which is highly regulated also, so is automotive piece. But energy is a very regulated industry as well. Not to kind of diminish the impact of it, but if an airplane goes down, you're talking, a few hundred fatalities, which is horrible in that sense. But you could have a disaster from the energy, any of the failure of the product could really have an environmental disaster. It could have, the operations could go down for months. And then fatalities can also happen. And you've seen those cases and probably heard in the news in there. So to kind of mitigate and de-risk all that, the industry has come up with, a lot of regulations and standards. And then all the products that we build towards it must qualify and certify towards those standards. And these standards typically go into enforcing disciplines towards your product design, your product manufacturing, and the quality practices that you do, right? Now, from the company perspective, we also have our culture of very, high quality products. So that's kind of ingrained in ours. So we typically go beyond what industry standards are asking for, because the way we look at ourselves is that we should be driving these standards and making more and more safer products. So from that perspective, when you bring the additive into picture, there are so much standards that go towards basically certifying a product that is additively manufactured. And for that purposes, we have to make sure we are putting together an infrastructure that supports this certification. Now, how would you put this infrastructure? You can do a traditional methods of it where you have processes. Even the non-traditional, non-additive manufacturing processes that it goes through to, digital tools. You have those tools are involved. Rarely products are manufactured now on a piece of napkin. They are using those in there. But what we see, additive becomes very important because in terms of digital, because essentially additive is a digital manufacturing. If you look at it, at the core of it, there is a fully digitized 3D model. You have to have that. You can't just throw a 2D, the paper drawing to do with it. Even if I give you that, first thing you're gonna do, convert it into a 3D model, and you slice it into it. So that's what you're doing with it. So that's one aspect of it. The second piece is the printer that you have that's printing it is equipped with sensors and cameras in there, and it's constantly giving you this gobs of data. And understanding that data is extremely important, because that understanding drives the quality of your product that comes out of that printer. So you have to understand, right? So you have that aspects of it. Then when you take let's say a case like additive build plate, where you're putting various parts in there, how much you can fit into that part, how you would arrange it horizontally, vertically, and then how you nest this, and then how you manage the thermal and residual forces around, stresses around it, determines how much you're going to produce. So all of that has to happen digitally. So the digital becomes core to additive. So from that aspect is, if we were to scale additive, we have to really find solutions which would scale these digital aspects. And that's what we've been working on it for, many years.
Yeah. And what's your outcome with that? Or like, what's your goal that you're trying to strive for when kind of combining these digital workflows and tools, software, files? Where do you know?
I think we really have few things that you can call it goals. These are areas that we want to achieve. So if you look at it, most of the work that we do in internal are for our internal product lines. We have about 20 different product lines. So we make pumps, we make gas turbines, we make completions, services, products, which basically goes into on the well, drill bits. So we have such a diversity. We have about 20 different product lines, along with various product families. So the way we are located, and then few of us in the additive technologies across the company, these are small groups who are supporting these companies. So the first thing first, we've got to make sure that we are able to support these product lines in such a diversity of product. Now, when I say that, because there are different types of products and services, they all have their different processes. They all have their different needs and markets. And to whatever digitally we're doing, whatever process we have for additive side, must be able to work in very interactively for these guys, right? Mm-hmm. At the end of the day, it's the technology. If you're looking at the higher level from a product perspective, I really don't care whether you cast or you make it additively, right? So from their perspective, is it cost efficient? It's faster for me. So all the values, and if that value gets stuck into somewhere in the process nuances there, because you have not streamlined it, then you lose out the value proposition. So that's the first thing that we were trying to do. But then at the same time is just setting up these repeatable and reproducible production processes. That's the other goal with the digital side of it. And then you finding a cost-effective solutions. That's an important part from our end. And then eventually, we want to make sure, which we have achieved it already, is to what we talked about earlier was the certification. All this data requirement that we have for our internal quality control purposes and the certification for supplier for our industry, we don't spend time manually collecting data from different source systems. We automate these things. So this is where digital comes very, very handy there.
Yep.
And now that basically gets us to kind of internally focus and then supporting our internal, company needs. But that will not help us to scale if we cannot have the same level of discipline enforced into our supply chain, which is supposed to be.
That's going to be my next question of
right?
You can do that internally, but how does
yeah, exactly. So now how do we do it externally, right? So all the disciplines that we are putting in place, we believe, and we're already seeing this there. We have to make sure our supplier base also have those disciplines. Mm-hmm. Now we cannot be there every time, everywhere for the purposes of watching them to do that, to do this, so we're connecting this digital network basically where supply base is connected to us. When we request a part to be printed at their site, we have a complete visibility to parts. We can remotely monitor and be alerted if there is a problem happen at, say, layer number 200, while there 5,000 are also need to go there, and we can tell our supplier that, look, you can continue to print it, but this print seems like it's not going to work for us because it's already carrying some defects into it. Yep. That may be a learning exercise, but it's not something that's going to go into production. Now imagine the value for even supplier also, because supplier was traditionally, they would do is they would run through the whole cycle, they do the quality control, everything, and towards the end they give you the inspection. They already sure enough, at the end of the process, we would come and look at the data and say, okay, well, this is not going to work. Mm-hmm. But that's a waste of time, waste of effort for them also, for us also. So, but if we have digitally connected this supply chain, we can do this, and we have proven this with some of our supplier base, where we were able to tell our supplier, stop, you don't really need to further proceed with this specific print.
Got it. Mm-hmm. And how is what advice would you give to some of those suppliers? So those kind of the folks that are helping support you and others in the industry, especially we hear a lot of the kind of the difficulty in how do we build a supply chain for additive manufacturing, right? What are the one or two things that you've learned, or you could kind of, hey, if you're running one of these shops, if you're thinking about kind of building or scaling this technology to support large companies like yourselves, is there something that pops to mind?
Yeah, I mean, one thing I would say is that don't underestimate the value of data. The data that your printers are generating, that your shop is generating, that's it's kind of gold for you. That would drive, if you can understand it, you can harness that value. Mm-hmm. You would basically excel, and it's not going to basically just help you to be efficient in some sense, meaning productivity and others, but on quality of the product, but also will give you insights where you can see the growth in your in your business opportunities there. Because in that data lies the lot of value.
Do you think it's kind of an afterthought now with a lot of folks?
I think it's still afterthought. The fact that you go there and then people are still trying to work their way out into, like I said, the Excel and others, right? And this is where it starts and this is where it ends. And then most of them basically create some PDF files. Mm-hmm. and then kind of give it to you, and then from then also is again it's the same thing is, this is no different than other technology.
Yeah.
Yes, in a sense, because it's one of the technologies, but it is giving an opportunity to look things differently in a digital world, in a digital sense, that casting hundreds of years been around, and forging that haven't given you because it was not there for it to start with.
Yeah. And so if you put on your kind of futuristic hat, what are you most excited about kind of looking forward in terms of the potential of data and the work that you're seeing and doing? internally and maybe even with your suppliers? Are there things from the industry that are exciting you? Is there current events, or what is kind of like, what do you think is going to propel kind of the work that you're doing forward in the coming 18 to 24 months?
Yeah, so I mean, one of the area that we think it could be really helpful, this the use of data and the digital, and the combination, really, because they go one or the other in some sense, is able to use create these digital artifacts from start to finish, meaning from a CAD model or a product design to a product, process recipe, the instructions, the steps that you need to do, and on all of that. If you can prove it out digitally for one part with the exact same supply chain, you are able to lock that in. And you do not need to create and produce as many parts that you used to do to just keep it in your stock. You would still need some, but then the opportunity comes in where you can balance your inventory with this digital inventory, has been called, to your physical inventory, because you have a clear sight to how long it's going to take you to print it. And the goal really is, because why you put some parts in your physical inventory, because the lead time really from that to your operation is the transportation time and the installation and setup time, right? And if you can translate that into a process where printer, whether it at a close to operations and a local supply chain there, which replaces this transportation time, which replaces this overall setup time, in a sense that you don't need to then put and create this physical inventory. And if you don't do that, you don't lock up your cash in there.
Yep.
And that is a big value for our customers, or ourselves as well, but our customers, because some of those parts that they keep it highly critical part in their inventory, just because if something goes down in the operations, it could cost them millions of dollars. Now, so they keep these parts in inventory for years. For years, some part just sits there for years, just in case, right?
Yep.
Those things are clear opportunities there. But the path to go through it is understanding the data, because you really don't know which part will make sense unless you really understand the data around it, which is where the data comes in, and where would make sense and where would not make sense. So this is why the understanding of the data is good, because not all parts need to be, you really don't need to spend so much time digitizing and then putting in place.
Yep. Yeah. So two more just kind of last fun questions. So is there a piece of advice you would give to either your younger self or folks that are starting to get into the additive manufacturing space in terms of how they should think about their career, or kind of opportunities that they should seek out to get relevant experience?
Yeah, I mean, I think, it's what I would go spend more time, I guess, now, because it's different. 20 years, it's up. So I think if they're pursuing engineering and if they're pursuing additive in this area, they really need to kind of start tying in the underlying technology with the business objectives. Because if you're coming out of college and you want to pursue an additive career or career in this manufacturing area, one of the piece that often challenging happens from switching from academia or just coming from colleges to industry is you are good what you learn in the tech side of it, but you struggle to translate that into a valuable solution or product, because it's just that's translating that to a business objectives oftentimes it's a struggle. So learn more about it. I mean, understanding, because this is kind of like you said, you asked that what would you have done. I probably would have spent more time understanding the business value of the work that you do, and then articulation there. I think that goes more. Sort of why statement often is missing.
Sure.
How is right away we get to it?
Yep.
Because we're engineer, right? Who cares about why? Let's just do it.
So final question. I've been asking this. We just released our first annual kind of 3 Degrees discussions book list, but is there a book or piece of media, podcast, or something that has particular impact on you in the last few years that you'd like to share with the audience?
There's a couple of books that are still there that I'm reading right now. There are a couple of books I can even show you. I don't know if it's good to show, but
yeah.
I don't know if it's a free publication or not. But these are two. I'll show you.
Yeah.
This is still I'm reading. So I like this one, the super intelligence. That's a pretty neat book. It's really,
put it up a little bit so we can see. There we go. Okay. All right. Nice.
Yeah. It's a pretty neat book. And then this is some short stories type. What would like AI? Oh, let's see, it's not showing yet.
There you go. Perfect.
Yeah. So this one I'm a little far ahead, and this one I'm still kind of sipping.
Yeah.
I would stay with one book. I just can't do.
I can't do that. I got to focus on one and then finish.
Okay. So for me, it's like I read some and then I just switch over there, and so and it's like eventually I'll finish it. But I have this. I don't think it's a good habit, but this is how it is. It kind of goes through, especially this one. The types. What would it take really to build the super intelligence, and what are the outcomes? And I would recommend people just kind of read it. It's very insightful for my purposes here.
Awesome. Cool. Well, thank you so much. Really enjoyed the conversation. Look forward to seeing you in the new year.
Yeah, absolutely. Yeah. Thanks.